Hey everybody, Mr. Piercy here, and in this video what we're going to be taking a look at is now that we've had an opportunity to talk about all of the types of quadrilaterals and their characteristics, can we identify what type of quadrilateral it is based off of what characteristics it has. So previously what you were given, you said, well, you have quadrilateral this, and because you knew what this was, you could conclude that it had these characteristics. Well, now we're flipping it around. We're saying, well, we have a quadrilateral that has these things. So what type of quadrilateral must it be? So here in this example, what we're looking at is looking at the two quadrilaterals on the left, we have opposite sides that are congruent to each other in both cases. Now, because of the slanted nature of this first one here, meaning this is the one I'm talking about right now. Looking at that one, pretty much everybody would be able to look at that and say, well, because we have opposite sides that are congruent to each other, that's characteristic of a parallelogram, and it does look like a parallelogram. So that would be fair to say, because opposite sides congruent to each other would be indeed a parallelogram. Now looking at the next one, this one here in blue, a lot of people are going to look at that one and say, well, the opposite sides are congruent to each other, and it looks like a rectangle, so it must be a rectangle. And if you tell me that that figure in blue is a rectangle, I'm going to ask you to identify where does it have right angles. And you can't say, well, it looks like it has right angles. You have to be able to justify in some way there's right angles there. So all I can conclude about those first two shapes is that they're parallelograms. I really don't like, I said that this was a rectangle because that's what the answer key was saying, but I'm telling you, if you answer that that is a rectangle, I will not accept it unless you can conclude that I have right angles or that I have diagonals that are congruent to each other, something along those lines. Same thing here with the square. If you tell me that that's a square because it has four sides that are the same, and that's it, all that tells me is that it's a rhombus, not a square. Unless, again, I have right angles or I have congruent diagonals, I'm not going to accept you telling me that that last figure is a square. So really what this should say is this one should say parallelogram. And this one should really just be a rhombus. Because unless you can tell me that I have some kind of unique thing about it, just because it looks like something does not make it so. So here, we don't really need too much more buildup than what we have already seen, because this is kind of like the conclusion of this particular unit. Go ahead and pause the video at this point, try answering problem number 1 here, and when you're done, hit play, and kind of compare and see what your answers look with mine. All right, so we have quadrilateral JKLM, and we have both pairs of opposite angles that are congruent. Well, what type of quadrilaterals meet that? If both pairs of opposite angles are congruent, that very much says that it is going to be a parallelogram. So rectangles, rhombuses, squares, all of those things have that characteristic, but without any other information. With only knowing that I have opposite angles that are congruent, the only thing I can claim JKLM to be would be a parallelogram. Now here, what's the most specific name that we could give to this? Because I have four sides that are congruent to each other, and that's all I really know, then we should really only say that it's a rhombus. Okay, we know it's a parallelogram because I have opposite sides that are congruent to each other, but because I have all four sides that are the same, that tells me it's a rhombus. Can't say it's a square, even though it looks like a square. Can't say it unless I have some additional information. So example 3 here, identify what type of quadrilateral this is. is enough information given to justify that it is an isosceles trapezoid? Well, looking at the figure here, one of the characteristics of an isosceles trapezoid is that the base angles are congruent. So those two work out. So as long as angle J is supplementary to angle F, and it works out to be that that also is 78 degrees, then we would be in good shape. So that's what I want to know. Are those are those two angles, are they going to be supplementary to each other? And in this case, when you say 102 subtracted from 180, we do get a 78 degrees. So yes, there is enough information here to say that it is an isosceles trapezoid. Alright guys, go ahead and pause the video here and try answering these two questions. And when you're done, hit play again and compare your work with mine. Alright, so what do we have? What is the most specific name of this particular quadrilateral? Well, looking at problem number 2, I have I have a 7 here and a 7 here, I have an 8 here and I have an 8 here. So the sides opposite of each other are definitely not the same, but I do have two pairs of congruent sides. So to me, that says that this is going to be a kite. So where did there we go. This is a kite because it has two pairs of consecutive congruent sides, and nothing opposite is congruent or parallel. Alright, so is there enough information to justify that here we have a rectangle? Well, in this case, I would be able to say yes, there is, because out of the quadrilateral having 360 degrees, I got 90, 90, 90, so that would be 270. So that means this angle here must also be 90 for the total of 360. Because the opposite angles are congruent to each other, it's a parallelogram. And because the parallelogram has right angles inside of it, then it must be a rectangle. So there's a lot of different ways that we could go about trying to identify the different types of quadrilaterals that it has. This is a very good lesson, because even though it's a short one, because it really makes you think about what are the characteristics of these figures and then work something out from there. So this is going to wrap up what we're talking about with quadrilaterals, and this will be our last lesson in this unit. If you have any questions about anything, you all know how to get in touch with me. Leave me a comment in the Google Classroom, send me an email, and I'll be happy to work with you on whatever questions that you may have. Until next time, guys, thanks for watching and take care.